Hey guys, it's Thomas Blanchette with BNR Dental Lab. And so what I was gonna kind of show to you today is I was going to show you just a little tips, tricks, and how to start to utilize the IPF software in your lab, whether you are a 60 partial a day lab, or you're a 1 partial a day lab, or you're a 1 partial a day month. One thing that we are really experiencing in our lab is a huge growth in our market, especially in the removable department. First, to give you a little background on me and why we're actually experiencing this growth is my main role in this lab as a lab manager is to really find out how to manage efficiency in our laboratory. Originally, I come from a fixed background. I really don't have any background in the removable department as of 2 years ago. But when I first picked up the IPF software, it came to us with the actual scanner when we made our purchase. I was actually kind of fearful of it. The reason I was kind of fearful of it was I wasn't a removable person. I didn't know what I was doing, and I really didn't understand partials. However, one of my technicians had the Air Force manual on partials, so I decided to pick it up and educate myself. When I started realizing that partials are not that hard once I started getting into the software and to the education of it. So once I actually started educating myself on like base plates, clasping, eye bars, rests, working, balancing, etc., there's only a couple common theories that you really need to know. So what I ended up doing is I just got some stone models, picked up the software, and just started playing around with it. Once I actually got playing around with it, I started R&Ding manufacturing processes and how we can actually take a digital file and make it into a workable object, kind of like what we did for crown and bridge and implants. So once I actually started doing that, I actually wanted to go into streamlining my RPD department. So once I went into my RPD department, I got a lot of kickback because they kept telling me I didn't know what I was doing, the fact that I was a crown and bridge guy, etc. But the one thing that we have at BNR is called a We Are BNR call to daily work. It's not the fact that we're fixed. It's not the fact that we're removable. It's not the fact that we're implants or ortho. BNR Dental Lab is unionized as a whole. And the one thing that has really implemented this unity is this IPF software along with implants, fixed, ortho, etc. So we started advertising this software after we found our manufacturing methods, and our fit and precision is what is starting to bring us a lot more new accounts. Our R&D, our technology, all the doctors are getting these new products that other labs can't produce because they haven't had this education that y'all are getting today. So this will be more of a hopefully this will give you the advantage you need to download IPF software and give you a really exciting experience into what you want to do to introduce or to streamline your IPF software department. So what we're going to go ahead and basically do is I opened up the IPF software and I went ahead and I made my basic dentist. I made patient Dr. Pepper. You'll see a lot of soda references from me. I love soda. I know, I'm in the dental field. So what we'll go ahead and do is open the new case. Now, when actually doing these files, some people like to input them as models and stuff like that. For me, it's really a streamline and an efficiency model, so I really don't do anything. All I really do is I just go into the scan phase. Once that loads, then I go ahead and let my scanner do its thing. Now, most of y'all are pretty much already familiar with all of this software, capture reduced, the dies. The one thing that I actually found out that I actually needed for the RPD reconstructions is that I needed to go to the complete reconstruction. The complete reconstruction is what will actually give you the best and most accurate model. So once you go ahead and click on that, capture area, there's really no areas that I want to really focus on except for the whole model. If you do capture area, you're going to be doing a lot more image taking than what you really want to do. So what I want to do is I want to go ahead and go to capture reduced. I'm going to go ahead and hit start. And basically what it's going to do is it's going to scan the whole model. From when it's actually going to scan the whole model, one thing that I like to do is I like to also give you all a little bit of other information onto how this software has also improved our workflow from all this. So the one thing that we actually found out in doing all this beta software is that we found out that if you grow way too fast, it can put you out of business. The reason it puts you out of business is late cases, not enough material, software crashes. All of these things can be a factor in what can eventually shut down a business if you grow too fast. What I like about this software is it's not overly complex and it's free. The complexity of it is a basic RPD software that can get you a good design over and over and over. That's what I like about this software. Other softwares out there are very complex and what I would compare to almost like an engineering software, to where you do have to be a RPD tech. You do have to be that person who that's all they do is RPDs. You don't have to be a versatile tech. You can do everything. You can do crown and bridge, you can do RPDs, and you just have to know the general basis of it. So once my model's scanned, I make sure that there's no areas. Now what I do end up doing is I end up having my technicians draw out my lines for me, and they will also draw out any designs on the model. I like to use a red pencil because it doesn't show up, but yet I can still see it on the model, on the designs. So that's basically what we do from there. I kind of want to capture this area. It's not like you have to capture every single area, but most areas work pretty well. So what we've done is we've went ahead and captured our model under complete reconstruction, due to the fact that if you end up doing the reduced reconstruction, it typically won't finish out the palette, which is in some designs where what you need. So then you just go to the model phase, close out the file. Once it does that, so going back to the thinking process, how we have grown from it is we were able to put physical numbers to paper. In doing the traditional method, what we found out was that it took an average of 30 to about 45 minutes from the model being out of the dupe to finishing the product in investing in casting. For an average complex to immediate complex design. Here, we're averaging 10 minutes. So 10 to 15 minutes per a case is not bad considering you're running a 3-to-1 ratio. That saves a lot on labor. That saves a lot on time. It specifically just saves, and you'll see this in the future on these cases, it specifically saves you in blockout, duplicating models. You can actually print these models and be okay. Nobilium makes a great air barrier for this case. So once you get your model, I just double inspect it, make sure all my features came out properly, which they do. And what I'm actually doing is I'm comparing them to the model right now, making sure that my lines came out okay. So once they do that, then I go to this run application right here. So once you hit run application, it's going to give you the IPF. Currently I'm running 15.1, which is one of the better ones that I like the most. So it gives us a fixed cost in manufacturing. What we found out is depending what way you want to do it. There are many ways to do this. You can take these designs and manufacture them in your MCX5. You can manufacture them in a 3D printer with casting material. You can manufacture them in a SLM manufacturing, which comes to you in the metal through different companies. I know on the website you can submit your RPD designs to Sirona and they will actually come back to you in metal, whichever stage you want them to do. So what I do is, after checking the model, I align my model just like I would any other case, and I like that, but I don't think I like what could be the path of insertion, which could be a little better. So I'm just doing this to the pre-step where we define the actual axis of insertion. It makes it a little bit easier. Go ahead and line it up right about there. Hit OK. So from here, it's just going to give you a straight down axis of control. What it will do is it will show you where your actual undercuts are and where possibly the blockout can be located. This is where it starts to not only pay itself back if it were at a charge, but it's free. So this goes straight into profit at this point right here, is that you don't have to block out the model and you don't have to dupe a blocked out model, because everything will be done for you in this software. So this is part one. So let's say I like it and I can go from there once it blocks out. So then it's going to show you where your blockouts are, all in here. So what I like to do from this point, these are my settings that I like. Every setting is going to be different in everyone's location, but just in the basic sense of things, what I like to do is I like to go back in and I like to remove some blockout, due to the fact that when these actually get manufactured, if you have any clasping, all you should really have to do is just open the clasping just a little bit and the framework should seat down. Personally, I don't like to sweat, especially in the dental field. So if you start sweating when you seat these things, you should be able to make just a little bit more adjustments, and these should be seating in no longer than 10 minutes. We actually have it as a standard in our lab that these should seat in faster than 10 minutes. Anywhere from 5 to 10 is our benchmark. Knowing that I am going to be putting some clasping right here, I'm going to go ahead and get rid of that. Be putting some clasping back here. Leave a little bit of undercut there. I'm going to be having my base plate here. I'm going to be doing some clasping here. And so basically I'll leave those undercuts. I like to leave a lot of the undercuts in the lingual area, except for where I'm really going to be producing some clasping, due to the fact that these things have to have a little bit of retention. So as long as it has a little bit of retention, we are a-okay. Alright, so then we'll just go right here. And if I'm speaking too fast, please let me know. I can slow it down. Sorry, I'm a very high energy person. Anytime I talk about IPF software, I get super excited because I just really like to share what this system and what it can do for your lab and how much it can help you. I just can't get over how much it has helped me and how well it's been for my lab. So once we got our block out, we got a little bit of undercuts, and we're going to hit OK, and we're going to progress forward. So what I'm going to do now is I'm not going to go into every single tool. I'm not going to go into what everyone does, the limitations and stuff like that. I watched the other training video on the IPF software by Mike Cirrus. You may want to look that one up. He really goes into a lot of good fine detail in which these tools and how they can help you and what you can really use for where. So that video might also help you as much as well. Now keep in mind, this design we're going to be doing an actual metal frame, so I'm going to be doing a little bit more in detail, and then after I go to manufacturing the frame is when I'll actually explain to you on how this can all start really adding to money. So the first thing I like to do is I like to add all my little accessories. So the first thing I'm going to do is I'm going to add my grid. It's a little too far. So one thing I also do want to express is that I am not the most experienced. I'm not the designer in my lab. While I do some designs, I have other people that I have actually started to hire because we've had so much growth. I can afford to get more people in here. I actually don't believe in letting techs go ever, due to the fact that because we've done this, my margin has gone dramatically down. So I can hire more people. So I have now been able to hire 3 more people in this department: a designer, a manufacturer, and another finisher, due to the fact that I'm saving so much time. That's one thing that I really like about this software, is that it's fast, efficient, and you can do it. So in this, you can determine your thickness, how far you want it, your hole size, and your squares, whether you want squares or holes on your border. Whichever one you really want. So the next thing I really focus on is I'm going to have a connector, and that connector is going to go do want to make sure that they all intersect right about there. Okay, and then after that I can go to a rest. Now I know some people like to do their base plates first, things along those lines. I don't know, I just like to get all my little accessories out. Oh, wrong area. Accessories out for a little bit of the reasons. I don't know why, I just do. So this rest is going to go in here. Now I'm bringing it down just because I know it's going to intersect with the... Yeah, let's go ahead and get rid of that. And let's go ahead and try to see if a connector will be more applicable. Oh, I clicked on the wrong button. Okay, where is it? There it is. Alright, so one thing I can do is I can edit my line. Make it fill in there. Alright, so then I can add another rest. Right about here. Now, I know these are looking to be a little bit thick, which that's still fine. It's not a really big deal. Okay, and then I'll go back in. and you can taper those in and taper them out, whichever one you really want to do. Now, a lot of the times, these, like I was saying before, the designs on mine will be a little bit flawed. But it is supposed to show you just really the purpose of why we adopted this software. Okay, so then I can actually go into my base plate. Make sure that everything is touching. A little too far. Alright, so while we're waiting for that to think and add that in, so one thing that we also found out in manufacturing these is that now we've surveyed, blocked out, and designed, and it's been only about 15 minutes from what I understand, 15 minutes to get the design, and now it's ready for manufacturing for investing. So you don't need to buy any more wax patterns. You don't need to dupe a model because this is already blocked out for you. That way you manufacture it, you go straight to casting, and everything should be good to go. So, sorry about that. This is kind of newer software to me. So then once you have all your areas designed, you go ahead and hit finalize, and it's going to group everything together. But that you are now ahead of the game because you've waxed everything up in less than 10-15 minutes. These are great materials where you can go straight into manufacturing. There's no warping, there's no wax, there's none of that stuff. That just kind of makes it, I don't know, labor intense. I'm not a big fan of doing it the traditional way. So now that you see that everything is bridged, everything is done, we actually have some other tools in here. What I like to do is I like to go back in and just make everything a really nice, smooth pattern. Because when you have complexity in your designs, you're going to have complexity in your castings. You can also add stippling and all that other stuff, but for demonstration purposes, I'm just going to kind of get this right about kind of where I want it. Alright, so just kind of smooth that down. It does encroach on the thicknesses a little bit, so once it encroaches on the thicknesses, you're going to have to double check a lot of this stuff. And plus, since that's really thick right there, guarantee you your metal finisher does not want to finish that down all the way. It's kind of like the theories of some of the other advocates. The more you do and the more you take care of your design, the less post-processing you have to do, which is also a really good thing, and other people will really love you for it, especially those people who are strictly CAD techs and not actual RPD people or anything along those lines. It will take care of it all for you. I typically never mess with the clasps. The reason being is our manufacturing in-house is CAD cast, which is computer aided design, and computer aided casting, which is done by Stratus, the Eden 260 VS. We take these designs, we print them, and we cast them in-house. So that's what we're doing right now, but there are other ways. So once I actually have everything smoothed out to where it's right where I want it. Now I know I don't want real thick rests. Those are going to be a pain in the butt to finish down in the casting assembly. So that's kind of why I stuck with where I stuck with. Maybe thin that up a little bit. But so that's pretty much it on the design of this one. All I'm really going to do is go back and I am going to add some sprue points. This is a really nice feature. I sometimes like to over sprue mine. But see, this is another thing you don't have to buy, is sprue wax, because it's all taken care of for you. And then I go back and I hit add material. I just like to bead them a little bit. Now, the one thing I do like about this is you can go back into your display objects, get rid of your model, and look at the intaglio of what you have. Now, careful, because this software can design and will design really thin partials, in which your manufacturer may call you sometime and tell you, hey, this isn't going to work. So what I end up doing is thin areas like that, I'll end up beading. That one looks pretty good. That one looks pretty good. And then after you go back to bead, you just go back to the smooth area. Smooth it down, just to give it a little bit more strength. Just to make it a really good design, is what you want to do. And you can smooth the beads, whichever one. Alright, so this is at the point where I would classify this as a finished framework. So what we would do now is we would just go to the analyzing tools, make sure that there is nothing under 1 millimeter or getting close to 0.5 millimeter. This I'm not overly worried about. Looks pretty good. So you can always check your designs in this area as well, which is what we always like to do. That way it guarantees us a good manufacturing product. So after that, we can go to export framework, test case. It automatically has all of these STL files already exported. Hit save, and boom, you're good to go. Now keep in mind, this is about 20 minutes on the dot, and we've done one framework. Now, and this is a training session where I'm explaining everything that I'm doing. Once you get proficient on this stuff, you can really start moving and doing some mover and shaker moves with your partial framework department, and you can really do some great things with this software. So after it's exported, then you just can exit out, and you should be good to go. I'm not going to save this design because I manufactured it later on in the week. But what I am going to do is usually during that time I'll open up a second page, relabel everything, and I will get this going. So what I'll usually end up doing now is I'm going to use the same design, but I'm going to show you how we actually do this in flexibles, which is basically just what we did, just with a lot less complexity. So now going back into the actual numbers of managing an IPF software once you've adapted digitally, is that now that you can CAD cast, you've saved all your labor, and you can either A, allocate it elsewhere, or B, you can take it down to your profit margin. That's the part where this really starts to make a difference. It's no longer stepping over pennies to grab a dime. It's now stepping over dimes to grab pennies. Again, like I said, we actually manufactured these frames in-house to where we cast them with Nobilium products. However, if you want to there's a Bago printer out there. That one's really nice. Envision Tech makes a really nice printer. That's nice. or you can send it to Sirona. That would start the SLM method. The SLM method in Sirona comes back extremely nice. I mean, there's really no need to finish them down other than electroplating, and that's really it. So yeah, that's basically how it manufactures itself. And the metal finishing time slows it down a lot, and then doctors are getting precision manufactured frames. It's no longer just an expert guy in his field. It's actually taking the person who's a general person and making him an expert in the computer. So now what we can do is, I'm just going to do like a little Nesbit or something like that for a flexible product. Valplast, TCS, Snow, whichever one you really have the favorite of is what we use here. So because this is duped and this model, or not duped, but this model is going to be blocked out, what you can do for flexibles is you have to have something to inject to. You don't have to have an investment like an RPD frame. And because it's doing this one, we have a new way of what you do is you print this. It's already blocked out. You go ahead and dupe the frame with the model, and then you remove the model, and then you have the framework inside, or the print, or whatever it is, and then you just pour stone back into there, and you now have a blocked out model. There's no, it's reverse engineering it. It's not blocking out a model, then duping it, then going to design. It's taking it backwards. Anytime you take it backwards, you cut 2 or 3 steps, and you get a lot faster. Speed and efficiency is what will make you the money. Literally. So again, same blockouts, same everything. You hit OK, check your blockout. Good stretch. Okay, so once you actually go to that, then you check your blockout. Now, frames for flexibles need a little bit more retention and a little bit more. That was ad. And a little bit more. So what I'll do is I'll go ahead and I will actually get rid of all that. Actually into the yellow. Sorry guys, I would show you a picture. I guess I forgot to introduce myself properly and give you a picture of what I look like. But if you want to end up finding out who I am, what I can do for IPF software, look me up on Facebook, Thomas Blanchette, or you can find me on our lab site, bnrdentallab.com. That way if you actually want to see who I am and I guess a picture or something like that, I got more excited about this IPF software. Okay, so once you go ahead and introduce a little bit more, you can go to, I like to use my base plate feature. Here's what I like about flexibles, is if you use your base plate feature, you have 1.65 millimeters all the way down to 0.25 millimeters, depending on the manufacturer and the recommendations. We are a huge TCS and a huge Valplast lab, so they recommend about 1 millimeter each. So what we can do here is you can just take your base plate, which will lead to here. Sometimes you can include your clasping in it. Sometimes you can get away with it, sometimes you can't. And keep in mind, these are all mucosal supported, so that's actually where they get a lot of their stuff. Great. So it looks like this one worked. Got a nice little set for Valplast in there. Maybe extend it a little bit more. Okay, so again, you can bring it back here if you want, depending on where you really want to go and where you want to put pressure or anything along those lines. Alright, edit line. Okay, so I'm kind of happy with that, and I want to make sure that this rests on the tissue, which is what I really like about this base plate feature. So my next step in what I'll end up doing is either A, I will print this and I will set my teeth on there, and then after I set my teeth, I will apply some boxing wax or base plate wax, and I'll send it out to the doctor for a try-in. So once I get that back, I already know the doctor makes the adjustments already. So I know exactly what fits in that mouth that time, that day. That was a huge advantage to us due to the fact that we don't have to reset anything. We don't have to do another base plate. We don't have to do anything else. All we do is what the doctor made in-house is what we process immediately. So we are guaranteed a perfect fit every single time. Plus, when doctors see a clear base plate, they're like, ooh, what is this? It's new technology. So then they get calling, hey, what is this? What are you doing? And you get your chance to show the doctor that you're not just some person in the garage or some person in a lab. You're a technician that knows what he's talking about, and they really listen and pay attention to those people who are really adapting new technology. So after that, all I really do is I will find... There's a pin in here. Where did it go? Seems to have eluded me. Anyways, so what then I'll do now is I'll just go to Finalize. Now, that was that manufacturing method. So keeping our ears to the ground, what we've started to kind of hear from different manufacturers, different companies, everyone, is that Best Buy has a really cool printer, and they're printing nylons, and they're printing all kinds of different materials. Now keep in mind that word nylon. What is TCS? TCS is a nylon. Valplast is not a nylon, but it's a thin injectable material that can be melted down. So what we hope to see in the future, again, this may or may not be existent, but what we hope to see in the future is that we can start processing to this. Like I said, maybe in a couple months, y'all will see some new updates, even some new manufacturing methods. Here in the future, I can share with you whatever I learn whenever I learn it. So one thing that we also had to do was we had to have block out for our teeth. So you're generally going to set your teeth here. You're going to set your teeth there. Now I usually do about 2 or 3 of these. And you're asking me, well, why do you do this? One, what we do is this is a 2mm hole, which is what they recommend for injecting the teeth. So I actually make my person fit the tooth to this area, and then that way you're ready to inject and you don't have to worry about drilling any holes. Because everything's already waxed down. Why take off the tooth? Make sure it's done right the first time, which is really what's leading us to an opportunity. Plus, like I was saying, is that if by some reason we were ever able to manufacture a nylon, what you can do is you can print this in your nylon. And then you take your printed nylon, seed it back to your model. After you seed it back to your model, then you just bring it in normal Crown and Bridge software, scan, design, and with no spacer, and mill your tooth in a multi-layered PMMA. Harvest Dental makes a beautiful one. And if you can use, what is the company that makes LISI? GC, I think it is. Correct me if I'm wrong. Don't hold me to that. I think whoever makes the LISI also makes a stain and glaze for temporary teeth and materials. So, full circle to what I've been kind of rambling on for on this design is that, one, you can print possibly in the future is what we're hoping for, is print a nylon. Secondary, add your retention here in the software. After you retention in the software, seat everything if you can do it, and then import and design your crowns on your actual base plate. Once you do that, then you actually use your MCX5 to mill your crowns. But I do know that other companies are making pink polymers and pink pucks. So it doesn't have to do that. So you can make a PMMA base plate and a PMMA tooth, put them together, cold cure them together, and then there's your little temporary Nesbit. This is also good for implants, to adapting soft gingival tissues. And literally, that's what you do, is you just export your framework, boom, and it's done that fast. That's what I really like about this software, is that, one, over the past, I'd say about 6 months, when we really started getting efficient with it, is we've cut our labor rate by over 42%. We've cut our material rate over, I believe it's by 10%, and we've actually adapted into new technologies that are causing doctors to buzz B&R Dental Lab as the word. Make this your laboratory. Take what I'm doing and implement it in your software, in your lab. I really want other labs to be the buzzword of your area, because when you're the buzzword, that keeps laboratories alive. It keeps the one man, the big man. It keeps all of us alive. And the reason we do this is not to keep a secret, but the reason I do this is to improve the industry as a whole, which is this IPF software. I really hope y'all have enjoyed what I've showed you today. It's definitely something that I'm very passionate about. If you do like what I've showed you and you think it can be improved upon, I am always down for having something to be improved upon. Questions, comments, concerns, my email is Thomas, THOMAS, .bnrdental@gmail.com, and that's B as in boy, N as in Nancy, R as in Robert. Fill out a survey, let me know how I did, see if there's anything that you want to see in the future. Maybe I can do more of these webinars for y'all and show y'all how to really get this going and start becoming movers and shakers in the industry. Alrighty, y'all, have a nice day. Thank you. Bye-bye.